Example x1, suppose sine s is 3/5, cosine t is negative 12/13, and both s and t are in quadrant 2. Find cosine s plus t. Where I would start is just notice this is one of our patterns. Cosine s plus t. Okay, cosine s plus t is that's cosine sine. And if you don't remember it, look it up. It's going to be cosine minus sine. Okay, so start there. Cosine minus sine. What you should notice at that point is that we've got 4 holes to fill in. 4 unknowns, basically. Wait a minute, no, they gave us 2 of them. Okay? They told me that sine s was 3/5, so we should be able to fill that in. And they told me that cosine t was negative 12/13, so we should be able to fill that in. Of the 4 unknowns, they gave me 2 of them, and I'm going to have to kind of clean up and figure out the other 2. Now, it drives me insane, the number of students that will just go ahead and fill in the other 2 holes. I have no idea what you're going to put in there at this point, but some students are just going to try and just put a 3/5 in there and a 12/13 or something like that just because they don't want to do any of the work. There's a lot more stuff to be done here, and we need to figure out what's in. They didn't give you all 4 of those blank spaces. They gave you 2, and we need to figure out 2. Okay? Now, the good news is you've done this before. Okay, you have done this kind of problem before, and you've done it kind of a lot of times. In Chapter 5, we did this a lot. Notice they're talking about S in quadrant 2. So what I would do, and we don't have to do it this way, but what I would do is draw a picture of S in quadrant 2. You've got this angle S in quadrant 2. We form this triangle. We did this a lot in Chapter 5. I'm drawing an angle in quadrant 2, but they tell me that the sine ratio is 3/5. And so since I know the sine ratio is y over r, I should be able to label 2 sides of my triangle, y over r. And since I have 2 sides of a right triangle, that is a right triangle, I should be able to figure out that missing side using Pythagorean theorem. And so if you want to go, x squared plus 9 equals 25, square root of 3 is square root of 5. Subtract 9, that's 16. Square root is going to give me plus or minus 4. Okay, I didn't notice where we are. X number is over there in that second quadrant, or where we are on the left side, that's going to be minus 4. Now maybe you recognize that as a 3, 4, 5 right triangle. That's a very common pattern that emerges. 3, 4, 5, but anyway. However you find that that missing side is negative 4. What I want to know is the cosine ratio. Looking at this picture, it's easy to tell the cosine ratio is negative 4/5. That's x over r. And so I know cosine s is negative 4/5. I can fill in that one hole. I don't know the other one yet, because the other one's talking about t. Sine t, okay? I need to know something about t. So I'm going to draw a different picture, okay? A different picture of t in the second quadrant. So pretty much do the same thing. We're going to have t in the second quadrant. Now notice what they gave me this time. They gave me cosine, and I know cosine is x over r. And so my x over r looks like that. And then I should be able to do Pythagorean theorem again. Pythagorean theorem is going to tell me y squared plus 144 equals 169. Subtract 144, so y squared equals 25. Square root, I'd get plus or minus 5. But notice where we are. In the second quadrant, we're upstairs. That's going to be a positive 5 value. Okay? And what I want to know there is sine t. Sine of that angle t is y over r, 5 over 13. And so I've got my 4th missing piece. I'm trying to fill in those holes, and once I fill in those holes, it's just about simplification. Okay? So once I've got all those holes filled in, I simplify. Negative 4/5 times negative 12/13 is 48 over 65. Minus 3/5 times 5/13, that's 15 over 65. We got 48 65ths minus 15 65ths is 33 65ths. And that's my answer. Okay? Cosine S plus T. We talked about the second quadrant for S and T. Cosine S plus T is 33 65ths. Now, down at the bottom, they say those values of cosine S and sine T could also be found by using the Pythagorean identities. I think it's a little bit harder, but what we could have done, instead of drawing those pictures, what we could have done was said, all right, I want to know cosine S. So I would say something like sine squared S plus cosine squared S equals 1. Okay. They gave me sine S was 3/5. So if I squared that, that's 9 over 25 plus cosine squared S equals 1. When you subtract and try to solve, if you subtracted 9/25, you're going to get cosine squared S equals common denominator, 25/25. We're subtracting 9/25 to get 16/25. Okay? If I'm solving this, I'm going to take the square root of both sides. Square root of both sides would give me cosine S equals plus or minus 4/5. But then you're saying, oh, okay, wait a minute, we're in quadrant 2. S is in quadrant 2. And so in quadrant 2, I would know that cosine is negative. And so that's how I knew that was negative 4/5. I don't think most of you are going to want to do it this way. I think most of you would much rather draw the picture. I know I would. Okay? We've drawn this picture and we've drawn these triangles a lot of times. And I think it's I don't know, I think it's faster for most of us to do that. But what they're saying is if you want to use the identities, you can use the identities. It's the same thing, but we would say it's 33 over 65.